Alright, let's talk about something that you've definitely seen written on light bulbs, appliances, and solar gear: watts. Watts are one of the most important numbers in the world of electricity because they tell us how much power something is actually using. Without watts, it would be a lot harder to figure out how much a toaster is going to pull compared to a laptop. But what are watts? How are they different from amps and volts? And how can you use watts to size things like your solar batteries or your power stations for your tiny home, RV, trailer, or home? So welcome back to the lab where our opinions cannot be bought. As you guys know, we don't only exist to give you honest feedback on solar gear and products. We also want to save you money where we can, so you can gain energy independence without needing an electrical degree. You guys can support the channel for free by subscribing. You can watch some of our other videos to help you guys learn, and you can check out some of our reviews when it's time for you to start getting into portable power or solar. Now, before we dive into the math, we're going to give you guys a quick history note. The term watt comes from James Watt, big surprise, an 18th century Scottish engineer and inventor who improved the steam engine. Now, he didn't discover electricity, but his work on power made him famous. The watt was later named in his honor as a unit to measure power. So when we talk about watts today, we're essentially paying tribute to the idea of measuring how much work energy can do at a given time. To get started, let's clear up the confusion between volts, amps, and watts. You've maybe heard this analogy before. Volts are like electrical pressure. It's how hard the electricity is being pushed. Amps are the flow of electrical current, how much is actually moving. Watts are the measurement of both of these combined to give you the total power. And the relationship is really simple. Watts equals volts times amps. So if you have a device that is running on 120 volts, which is most regular household appliances, that's pretty much what you'd be plugging directly into, and it pulls 2 amps, it's going to use 240 watts. Think of it like water in a hose. Voltage is the water pressure, amps is like the thickness of the hose, how much volume of water is actually moving through it, and watts is how much water ends up leaving the pipe at the end. If you have high voltage, you have water moving very fast. If you have high amperage, you have a lot of water within a pipe. And then combining those two, imagine a small garden hose, low pressure, low water volume, and not a whole lot comes out. You have something like a fire truck hose, high pressure, high water volume, and a lot of water coming out. Now, when we say watts, don't get it confused with watt hours. There is a difference between the two. Watts is the first half of the equation. Think of this like miles per hour. If you're using 50 watts, it's like driving 50 miles per hour. If you use 50 watts for 1 hour, you will use 50 watt hours. Same as if you drive 50 miles per hour for 1 hour, you will have traveled 50 miles. But we don't want to get too ahead of ourselves. We'll get to that in a minute. Anytime you want to know how much power a device is drawing right now, you look at the watts. A laptop charger might say 60 watts. A mini fridge might say 120. And a microwave, 1,000 watts or maybe even more. That watt number is a snapshot of how much power is being used in that moment. So let's put this into a real world scenario. Let's imagine that we're going to be setting up a solar power station for a tiny home. So step 1 is figuring out your running watts. You want to go around your house, add up all of the watts of your devices to figure out the total power draw at any given moment. Let's say that first off you have LED lights at 40 watts, a mini fridge at 120, a laptop at 60, and maybe a small fan at 50 watts. Add all of those up and your home is pulling about 270 watts at any given moment when they're all on. That is your total power demand in watts. So now here is where your watt hours comes in. Now, watt hours are different yet the same. They measure how much total energy is used over time. The difference between watts and watt hours is a fairly common point of confusion. And what it really comes down to is power versus energy. So let's break it down carefully. A 50 watt lamp at this very moment is consuming energy at a rate of 50 joules per second because 1 watt equals 1 joule per second. We don't want to make this too confusing, so let's just think about speed in your car. 50 miles per hour is how fast you're going right now, not how far you've gone. Watt hours measures the energy used over time. If the 50 watt lamp runs for 1 hour, it uses 50 watt hours. This is like your car traveling 50 miles per hour for 1 hour. You covered 50 miles. The speed or power is constant, and the distance or energy accumulates over time. Using the same example, if you ran that lamp for 2 hours, it would consume a total of 100 watt hours. And if you only ran it for 30 minutes, it would consume only 25 watt hours. So the analogy that we like that's really simple is power equals the speed of the car, and energy equals the total distance driven. power equals watts, energy equals watt hours. So back to our example. If your power station has a capacity of 1000 watt hours and your tiny home setup is using 270 watts continuously, you take the 1000 watt hours, divide it by 270, and you would get about 3.7 hours of runtime out of your battery, or about 3 hours and 40 minutes. So this is why watts and watt hours are so powerful to understand. Watts is the power needed right now, and watt hours is how long you can run that power before the battery dies. Well, I hope that this can help you guys out when trying to understand solar or portable power. Next time that you're looking at a power station or your battery setup, you can think back to how many watt hours am I going to need after taking into consideration your total watt consumption over time. If you guys enjoyed this video, please subscribe to the channel down below. It's a free way to support us and show us that you guys like what we're doing. Otherwise, that's all we got for you guys. Thanks so much for watching. Peace out and stay charged.